Logarithms. Logarithms are directly related to exponentials. They are actually the inverse functions of exponentials. That means if we were to have a to the b power equals c, this would imply log base a of c equals b. For example, 2 to the third power equals 8, so the log of base 2 of 8 would equal 3. The logarithmic function equals log base a of x. Here, the base is positive and not equal to 1. In order to sketch the graph of a logarithm, we're going to consider the graph of an exponential. So we'll start there. Suppose f of x equals a to the x. Remember the helpful points there are -1, 1 over a, 0, 1, and 1, a. Since logarithms are the inverse functions of exponentials, to get our helpful points for logarithms, all we have to do is switch around the x and y values of the exponential. So our first point would be 1 over a, -1, 1, 0 for our second point, and then our third would be a, 1. This also affects the asymptote. For an exponential function, the asymptote is at y equals 0. For a logarithmic function, the asymptote is at x equals 0. So if we sketch our graph, it'll look something like this. With the vertical asymptote at x equals 0, we can sketch our first point at 1 over a, -1. So we can just assume that it's definitely less than 1 here. 1 over a, -1, 0, 1, a1. So let's just pretend a is some number out here, positive 1. And we can use the asymptote to help us sketch our logarithmic graph. So that's how we can start the graph of any logarithmic function. The natural log is a logarithm with base e. Log base e of x can be rewritten as ln, in which we call the natural log. So if you ever see ln, that implies that the base of the logarithm is e. We also have the common log. The common log is a log with a base 10. This is often how a logarithm will appear on a calculator. Logarithms have some particular properties that help us simplify things. For example, if I had log base a of 1, this will equal 0. A to the power of log base a of x will simplify to x. Log base a of a to the x will also simplify to x. And log base a of a equals 1. We also have the laws of logs. The first law is our product rule. Log base a of a product can turn into a sum. Log base a of the first factor plus log base a of the second factor. Similarly, we have a quotient rule. If I had the log of a quotient, a divided by b, this will simplify, or rather this could expand to log base a of a minus log base a of b. The third law says if I have a log base a of a to the power of c, I can change that by pulling the c out in front and turning that into a product of c times the log base a of a. We also have one more property It's going to fit here in the corner. We call this the change of base formula. This is helpful when you're calculating logarithms and using a calculator that doesn't allow you to choose your base. The log base a of x could be the common log of x divided by the common log of a. So for example, if I had log base 7 of 3, I can use the common log of 3 divided by the common log of 7. And that is all.